Hello everyone and welcome to today's programming video. Today we will solve the Leetcode problem to find the maximum product subarray. In this problem we have been given an integer array nums and we need to find a contiguous non-empty subarray within the array that has the largest product and return the product. So we have here an array nums with these four values. Now first of all, what's a subarray? A subarray is nothing but contiguous elements. So for example, the numbers 2 and 3 form a subarray, or 2, 3, minus 2 can form a subarray, or 3 minus 2 and 4 can form a subarray. But the numbers 2 and minus 2 cannot form a subarray, or the numbers 3 and 4 cannot form a subarray because they are not contiguous. Now let's try and understand what is the product of a subarray. If we take this subarray here, the product of all the elements is 6, and if we then compare it with the product of elements of this subarray, which is minus 6 or negative 6, this subarray, and that's negative 24, this subarray is negative 8, or even the entire array is negative 48, we see that the maximum value here is 6. So this is the maximum product subarray value that we need to return. Now let's think about how we can implement the solution. A basic naive approach might be to find subarrays at each individual index and then calculate the product of all the elements of that subarray. So if we look at the index 0, we can say that the subarrays are the array at index 0 and the array at index 0, 1. And then the next one is including 0, 1, 2 indices, and finally it is the values at index 0, 1, 2 and 3, and then we calculate the product of each of these subarrays. So here it is 2, in this case it is 2 times 3 is 6, and we keep on doing that till we find all the products, and then we pick the maximum, which is 6 in this case. Then we go to the next index. So let's say the maximum product subarray at this index was 6. Now we go to the next index, and that is index 1. We calculate the subarrays again here, here and here, and we calculate the products of each of these subarrays. So we keep doing that till we iterate the entire loop. Now this will be rather inefficient, and the complexity of this will be O of n square, where n is the size of this array. And the reason it's O of n square is we first need to iterate the entire array, and for every index we need to iterate the array again to find each of the subarrays. Now I will discuss 3 different scenarios which we need to consider. One is when we have positive numbers, and that is the most simple scenario. If we have all positive numbers like this here, so it's 2, 3, 2, 4, the maximum product subarray is the entire array, or the product of elements of the entire array. So the answer in this case will be 48. The other scenario is when we have negative numbers, and that makes things complicated because if you multiply a positive number with a negative number, you get a lower negative number, whereas if you multiply 2 negative numbers, you get a larger positive number. And the third edge case, or the third scenario, is when there's a 0 in the array. So let's discuss a solution which tackles all these edge cases and gives us the right outcome. So let's look at this example where we have a mixture of negative and positive numbers. So the first 2 numbers are negative, the third number, or index 2, is a positive number, and the last one is a negative number. If we break down this problem into smaller subproblems, we can use a dynamic programming technique, and let's try and work it out here. So let's say we calculate the max product subarray at every index using the max product subarray at the previous index, which means we need to firstly know what is the max product subarray at every index before the current index that we are calculating. So in the case of index 0, the max product subarray is -1 because that's the first element. And for index 1, let's say the max product subarray is the current number, negative 2, times the max product subarray at the previous index, and that is -1, and we get positive 2. Okay, so now let's move on to the next index, and here we can multiply the value 3 by the max product subarray value at the previous index, which is 2, and we get a 6. Moving on to the next index, we multiply -4 by the max product at the previous index, which is 6, and we get negative 24. Now here, according to this, our largest value is 6, but it is the wrong answer, because if you look at this sub-array here, right, we could have got a larger number. So if we had multiplied negative 2 and 3, we would have got negative 6, and if we multiplied that with negative 4, we would have got 24, which is the highest possible value or the product for any given subarrays. So how did we miss that number? By simply using the calculation of multiplying the current index value with the max product subarray at the previous index. So let's go back a couple of steps and figure this out. Now, because we have a mixture of positive and negative numbers, and we know that two negative numbers when multiplied together produce a larger number, and even though we're calculating the max product subarray, we also need to keep track of the minimum product subarray. So a minimum product subarray is the smallest number that we can produce by multiplying the numbers. So let's look at how we can use that idea and get our answer. So in this case, we'll see that the max product subarray at index 0 continues to be -1, so that's fine. Now we will calculate the max product subarray at index 1 as -2 times -1 like before, which is 2 here. But we also want a minimum product subarray. Now in this case, the minimum product subarray is this number -2 itself. So let's write that down. Let's call the bigger of the two number as current max. Okay, so I'm just going to call it C max equal to 2, and C minimum equal to -2, -2. So we have now max product subarray and minimum product subarray for this index. And now as we iterate, we want to make sure that we keep track of the largest product for every iteration. So we can call that variable called max so far, and in this case it will be the larger of the two, and that is equal to 2. Okay, let's look at the next index and it will make it clearer. As before, multiply 3 with the max of the previous index, and that would give us 2 times 3 equal to 6. But we also multiply 3 with the minimum at the previous index, so we get -2 times 3, and that is -6. Now you can see that we have both values here, a larger, a positive max max product and a min product. The min product is -6, so we're tracking both of them. So which of the two is larger? So 6 is larger, so let's say C max equal to 6 and C min equal to -6. In this case, now let's see, the max so far was earlier 2, and the C max here is 6, so we'll overwrite max so far and we'll say max so far equal to 6. Now let's go to the next index here. So we'll again do the same thing. We'll multiply -4 with the max at previous index times 6 is -24, and we'll multiply this -4 with the minimum at the previous index. Okay, so that gives us 24. Now if you look at it here, compare 6 and 24, 24 is larger of the two, so we'll say max so far equal to 24, and this is our return value. So let's look at this again. So at let's say we are at index 2 here, and we're calculating two products. Let's call it product 1, and let's call this one product 2. Product 1 is nothing but the current the current number 3 multiplied by the max product subarray at index I-1, and P2 is nothing but the current number 3 again multiplied the minimum product subarray value at the previous index, and we get two numbers here. The larger of the two, I'm going to call it C max, and the smaller of the two, I'm going to call it C min. And finally, what I'm doing is I'm saying set max so far equal to larger of the two between max so far and C max. I do the same again here as well, and I continue doing it till my loop is finished, and I've iterated over through the array, and I will return max so far at the end of it. Now let's look at another example where we have a 0, and we'll improvise upon this algorithm to make it work. So in this array nums, we have all the different kinds of numbers. We have positive numbers, we have a 0, and we have negative numbers as well. And if you look at the array very quickly, if we multiply this first section here, first sub-array product is 4 times 3 is 12, 12 times 1 is 12. So the max product sub-array here is 12. We can't use 0 because anything multiplied by 0 is going to be 0, so that's out of the equation. But the next part of this array is this one, this sub-array. Minus 2 times minus 8 gives us 16. Because both numbers are negative, we multiply them together, we get a positive number. And the answer to this question or this input array will be 16. Now let's improvise upon the logic we just discussed to make sure we account for this 0 and get this correct answer. So what remains same is that the max product sub array at index 0 remains the same. So let's write down the values for index 1. So as we just saw earlier, let's call them C max, which is the maximum product sub array at this index. 0 is 1, and the minimum C min is also 0. So the minimum product sub the minimum product sub array for index 0 is 1 as well, and we'll initialize max so far to be the first element in this array as well. Now let's move on to the next index in this array, and we have the number 3. So we need to calculate the two products here. The first product is P1, and it is, what is it? So 3, which is the number here, multiplied by the max product subarray at index I minus 1. So that is 3 times 1. Okay, and the product 2 is 3, which is the number here, times the minimum product subarray, which is 1, and both of them are 3 here. So that's fine. Now, when we are calculating the max product subarray, we need to calculate not just the larger between these two values, but also compare it with the current value here. And you'll see in a minute why this is important. And this is where the 0 is going to be a good example. So our C max here, right? So C max will be the maximum or the greatest between P1, P2 and the number at the current index, which is 3, and that is equal to 3. So P1 is 3, P2 is 3, and the number itself is 3. So we'll say the max product subarray at this index is 3. Now what is the minimum product subarray? So let's call it current minimum, and it will be the minimum between the P1 and P2 like before, P1, P2, and the current number, which is 3. So C min here is 3. Now we'll have to update max so far here because 3 is larger than 1. So max so far becomes 3. So that's updated. So now we are at index 2, and we want to calculate these numbers again. So what is P1 now? So P1 is current number 4 times the max product at the previous index. So that is 4 times 3, 12, and P2 is the current number multiplied by the minimum product subarray at the previous index, and that happens to be 12 as well. So because that's 3 times 4, 12. Now we need to calculate the max product subarray value at this index, and that is C max. So C max here is the maximum between this 12, and this 4, and the maximum is 12. So the minimum product subarray, I'm calling it C min, is the minimum between these three values, and that's 4. Now 3 is less than 4, so obviously we'll update max so far to be equal to 4. So that's updated here as well. At this index 3, we get a 0. P1 equal to 0, and when we multiply this number 0 with the minimum product 4, we get 0. So P2 is 0 as well. The maximum product subarray will be the maximum between these three values, and that is 0. So we have C max as 0, and the minimum is also 0 because between these three values the minimum is 0, and we leave max so far at 4 because 4 was already larger than 0, and this is why we need this max so far, otherwise we're going to lose track of what is the largest so far. So now let's go to the next index, and this is where we see the difference, why we need to calculate the three values and not just P1 and P2 to find the minimum and the max product subarray. So at this index 4, what is P1? So that is -2 times 0 is P1, that is 0. And what is our P2? P2 is -2 times the minimum product subarray, and that is also 0. Now what will be our max product subarray for this index? 0 is the larger of the three, so the max product subarray at this index is 0. But what about the minimum product subarray? If we had not taken this number, okay, we would have got a 0 here, and then anything multiplied by 0 after that would have given us a 0. But what we're doing here is we're saying find me the minimum between the current number -2, 0 and 0. So the minimum of these three is -2, and that is what happens here now. So we retain this value -2. If we had not compared this -2, we would have lost it, and we would have gone with a 0, and we would have tried to multiply this -8 with a 0, and our result would have been incorrectly 4. So at this point the max is 0 and our max so far stays the same, which is fine, because 4 is greater than 0. So far it is the largest product that we have calculated. Now coming to this last index, the number is -8. So let's calculate the first product, which is the current number times the max product subarray at the previous index, and that happens to be 0 because -8 times 0 is 0. And now let's calculate the second product, which is the number times the minimum product subarray at the previous index, which is now -2 times -8, and that gives us 16. So I hope it's clear now why it is important to compare not just the previous max product and minimum product, but also compare it with the current number at the current index. So we get 16 here, and now our Cmax, what will our Cmax be? It will be 16 because 16 and 0, 16 is larger. C minimum will be 0, the smaller of the two, and our max so far will be 16 because 16 is larger than 4, and this is what we need to return. Firstly, we'll check if our input array is of size 1, and if it is of size 1, we just need to return that first element. So both the max product subarray and minimum product subarray at index 0 form the base case, and we'll also keep track of the max product so far in a variable. Let's start the loop at index 1. I'm going to calculate the two products. The first product will be the current number multiplied by the max product subarray at the previous index. The second product, P2, will be the current number times the minimum product subarray at the previous index. Now the max product subarray at this index will be the maximum between the current number and the larger of the two products, and the minimum product subarray at this index will be the minimum between the current number and the smaller of the two between the two products. And because we want to keep track of the largest product so far, we will update the max so far to be the greater value between max so far itself and the max product subarray at this index. And we'll exit the loop and we will return the max so far variable value. Let's give this a run. Okay, that looks good. Thank you very much for watching. I hope you find this video useful. Please do remember to like and subscribe. Thank you very much. Bye.